This will be our third problem solving session for Chemistry Paper 2 of IITJEE 2008. In this session, students, we will be solving the comprehension linked question as well as the matrix match type of questions which were there in that paper. So now let's start our problem solving session here. See, the comprehension which was there is in hexagonal systems of crystals. That is, it is talking about the hexagonal system when in 2D the particles are arranged in a hexagonal manner. Right? A frequently encountered arrangement of atoms is described as hexagonal prism. Here, the top and bottom of the cell are regular hexagons and 3 atoms are sandwiched between them. You can visualize this. A space-filling model of the structure called hexagonal close packing is constituted of a sphere on a flat surface surrounded in the same plane by 6 identical spheres as closely as possible. 3 spheres are then placed over the first layer so that they touch each other and represent the second layer. Each one of these 3 spheres touches 3 spheres of the bottom layer. Finally, the second layer is covered with the third layer that is identical to the bottom layer in relative position. Assume the radius of every sphere to be r. Now let's first draw the structure. See, this is the arrangement it is talking about. There is a sphere at the center surrounded by 6 spheres as closely as possible, making a hexagon. Above it, there are 3 more spheres in the second layer. These 3 spheres touch the 3 spheres at the bottom layer. Then again a layer identical to the first one is placed above. See, this is the 3-dimensional structure of that. We have got 6 spheres at the bottom, 1, 2, 3, 4, 2 at the back, and there is a central sphere. Right? So this is your central sphere to which other 6 are attached. Then what we said, that there are 3 spheres. See here, a sphere on a flat surface surrounded by on the same plane by 6 identical spheres as closely as possible. So see, it is in the center and there are 6 identical spheres as closely as possible in the first layer. You can see it here. Then 3 spheres are then placed over the first layer so that they touch each other and represent the second layer. Sorry. See here, these are the 3 spheres. 1, 2 and 3. These are the 3 spheres. They are touching each other and they represent the second layer. Then what was it? Each one of these 3 spheres touches the 3 spheres of the bottom layer. See, 1, 2, 3, it is touching what? 3 spheres of the bottom layer. Then, finally, the second layer covered with the third layer, that is, second layer is covered with the third layer that is identical to the bottom layer in relative position. So, this is the first layer, this is the third layer which is covering the second one and it's identical. It means that these 3 spheres are touching the 3 spheres above also. Right? Now you have to solve the question. So this is a 3-dimensional structure of the HCP lattice and this is your structure, how the bonds are present between them. The number of atoms on this HCP unit cell is. Now what you have to find out? You have to find out the number of atoms in this HCP unit cell, right? How will you find out? See, there are 3 in between. So these 3 are not shared by any of the unit cells. So I can write it as 3 into 1. The contribution of these 3, each particle is 1. Now, there are 2 atoms at the center, one here and one here. So they will be shared by one another cube above and one another cube below. So they will be shared by 2 unit cells. So what can I do? I can write here as 2 into 1 by 2. That is, contribution of this particular atom will be 1 by 2. How? Because there will be one more cube above it. Fine. Now, we have got the particles at the edges of it, at the vertices of it. See, 1, 2, 3, 4, 5 and 6, 7, 8, 9, 10, 11 and 12. Now these particles, each and every particle at the vertices is further shared by 6 cubes. Right? So I can write it here, its contribution to be 1 by 6. This would be 1 by 6. So how many particles are there all in all? How much? How many? This will be 1 and this would be 2. So it comes out to be 6 particles per unit cell. So how many particles are present per unit cell here? 6 particles are present per unit cell. Right? You can visualize this. There will be 6 unit cells, the above and below. Okay? So the 6 particles are present, or 6 atoms are present in this HCP unit cell. So for solving such type of questions, you need to visualize the 3D structure of that particular cell.